Let's solve a problem about particle motion where we need to show that the acceleration is negative and proportional to the cube of velocity. We have a particle moving in a straight line, such that its distance s is equal to the square root of time t. Let's visualize this motion. Here's our time axis and here's our position axis. The particle's position follows this curve, which is the square root function. As time increases, the particle moves along this path, but notice how its velocity changes. Let's solve this step by step. First, we need to find the velocity by taking the derivative of position with respect to time. Using the power rule and chain rule, we get that velocity equals 1 over 2 square root t. Next, let's find the acceleration by taking the derivative of velocity with respect to time. When we differentiate this expression, we get negative 1 over 4t to the 3/2 power. Notice that this acceleration is negative, which means the particle is decelerating. Now, let's show that this acceleration is proportional to the cube of velocity. First, let's cube our velocity expression. When we cube 1 over 2 square root t, we get 1 over 8t to the 3/2 power. Looking at our acceleration formula, we can see that acceleration equals negative 2 times v cubed. Therefore, we have proven that the particle's acceleration is negative and proportional to the cube of its velocity. The proportionality constant is negative 2.